Warning: the video you're about to watch contains mathematics at the level of pre-calculus. All material has an assumed prerequisite of college algebra and trigonometry. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. If you're watching this video, it's because you're in pre-cal and you have already gone through everything you need to know about exponentials in your previous courses and then in my review videos for pre-calculus here. And then you've just finished my very brief review of log properties of logarithms. So now we are going to go into expanding or using those properties. And this video is all about probably one of the most critical elements that you can have with logarithms in a pre-calculus course or in a calculus course. In calculus, you will often take an expression like this and expand it. And that's why you learn this skill in algebra, and then you review it in college algebra, and then you review it again in pre-calculus. So it's very important that you know how to do this. Of course, if you're in calculus, you'll be doing this with an expression involving only one variable when you're in single variable calculus. So in this case, we have a kind of wild set of variables here, but let's just go ahead and do this. All right, so the property that I'm going to use, let me hop back and showcase it. I'm going to use a combination of these two properties right here, and likely the third one down there as well. So I'm going to use those three pretty much exclusively with this problem. All right, let's do this. So using the fact that we know the fourth root, oops, let me use a right color pen here. Since we know that the fourth root is the same thing as the 1/4 power, I'm just going to trade out that fourth root for the 1/4 power of stuff. Now, I don't really need to, I should be able to rewrite all that. But the reality is there's no need for me to rewrite it right now because I'm using a property of logarithms that says if everything within that logarithm is raised to the same power, you could take that power to the outside of the logarithm. So we're going to go ahead and do that here. So this is 1/4. Now it's the natural log of that stuff being the stuff that was inside the fourth root. So we'll go ahead and copy that down now because it is kind of important for us to have that. So we have x squared, y cubed, square root, z times the square root of t all over e to the 6th times the quantity x minus y squared. Now, I'm sneaking a lot of stuff into this problem because you're in pre-calculus. You should be able to handle something super complex like this. So the next property I'm going to use is the fact that if you have, actually, you know what? Since you're in pre-cal, I'm just going to say it all at once. You have dealt with this stuff for so long, you should just know things in the numerator, all this stuff, will be positive logarithms. The stuff in the denominator can be pulled apart into negative logarithms. And remember, when you have products, they are sums, and when you have quotients, they are differences. Well, everything's going to be a product here. So let me showcase what I mean. We have 1/4 times something. Notice I'm putting big old brackets here because I'm going to have a large expansion. So I look at that numerator and I say, okay, great. That's going to be the natural log of x squared plus the natural log of y cubed plus the natural log of the square root of z square root of t. And that is because it's a product of objects or factors in the numerator. So because they're in a numerator, they're all positive, positive, and positive. And then in the denominator, it'll all be subtractions. So I'll have a subtraction of the natural log of e to the 6th, and I'll have another subtraction of the natural log of the quantity x minus y and quantity squared. Be very careful with how you're writing your grouping symbols, because it's very easy to mistake that x minus y squared within the natural log as being x minus y and then squaring the natural log. That's two totally different things. All right, so that is kind of a move that you should be used to, that things in the numerator end up breaking apart into logarithms of sums, and the stuff in the denominators will be differences with logarithms, or subtractions, I should say. And now I'm just going to use the fact that powers can be pulled out. So all of these powers can be pulled out here. I'm going to write this, but it's the 1/2 power on that picture. The 6th power can be written out here, and the 1/2 power can be written out here. So I'll go ahead and zoom out and do that mathematics. So I have 1/4 times a big old group of things, 2 natural log of x. So that one's pretty much done, completely expanded out, plus 3 natural log of y, plus 1/2 natural log of z root t, plus, let's see, what else we have? Oh, I'm sorry, minus 6 natural log of e, and minus 2 natural log of x minus y. All right. Now, this is not completely expanded because of a couple things, actually. We have one picture right here that can be expanded even further. And this picture right here, natural log of e is just 1. Again, from your prerequisite material. So we'll go ahead and just do this as 1/4 times 2 natural log of x plus 3 natural log of y. And now I'm going to say plus 1/2. Remember, this is a product of two objects. So I'll do it this way. Natural log of z plus. And once you're super used to logarithms, which you should be at this point, you just say that's 1/2 the natural log of t. You should be awesomely okay with that. And then minus 6 times 1, and then minus 2 natural log of x minus y. Something to note here, that natural log of x minus y, which the L didn't look right to me, that natural log of x minus y is done. You cannot break that apart. There is no property in that list of properties that we had on the previous page in the previous lecture there. There's no property that says, oh, if I have the natural log of m minus n, or if I have the log of m minus n, it splits apart. There's no property in that list that says that. So whenever you see a logarithm where its argument is a sum or a difference, it's done. There's nothing else you can do there. The second thing I want to note is some people will ask, is this really done, or could I distribute that 1/4 into each of those terms? You totally could. However, then they'd all have a 4th that you could factor out. So I kind of feel as though leaving the 1/4 outside is perfectly fine. That's just my personal opinion. The one thing I would say you should do here is clean up that middle set of brackets there. So I'm just going to do that right now. Just distribute that 1/2. So I'll have 1/2 natural log of z plus 1/4 natural log of t, and then minus 6 and minus 2 natural log of x minus y. There's nothing else you really can do that I see here. There are no like factors, so you're pretty much done. And yes, like I said, you could totally distribute that 1/4 through, but there's no real point to do that. So that was our expanding a logarithm example. And then we're going to combine logarithms here. And combining logarithms, it happens, but not as often as expanding them. But still, you should know how to combine logarithms. Now, I do want to mention, there are some domain issues with both of these problems, in fact. If I hop back to the previous example, you will see that the original problem that was handed to us, they didn't really care about domain issues. And you really shouldn't. With multiple variable functions like x, y, z, t that we have here, it's really difficult to worry so much about the domain issues here. There's way too much going on. So normally in a situation like this, I wouldn't pick on somebody and say, well, what about the domain issues? There are some weird domain issues with this. For example, t must be positive, right? It can't even be, by the way, 0. Because if t were 0, then that whole entire numerator would be 0, and you'd be taking the log of 0, which does not exist. Z must be positive because it's underneath a radical and it's multiplying a positive number, so it must be positive. And again, it cannot be 0 because the entire numerator would become 0. X cannot be 0, but it can actually be negative, and Y must be greater than 0. So there are some weird things here, but again, these are statements that somebody would not expect you to state if you have multiple variables. However, in the problem that we're looking at here, paying attention to domain issues is kind of important. So let me start by mentioning off to the side. Actually, no, I'm going to start just by answering the question. Let's combine these logarithms. Well, if it's a subtraction, which it is, of logarithms of the same base, that's critical, they have to be the same base, then you can just glue them together, right? As a quotient. I'm sorry, as a fraction. So here we go. So it'll be x squared minus 1 over x minus 1. Now, obviously, you can do a little good old algebra here. The x squared minus 1 is a difference of squares, and so when you do that, you get the log of x plus 1, because x minus 1 over x minus 1 will cancel, and you're left with the x plus 1. Notice I skip steps as we move forward in mathematics. However, there's an issue here. Because I removed part of the problem, I removed part of the domain issues. If I take a look at, I'm going to write this in red because it's wrong, but if I take a look at the argument there, you would say, oh, well, x plus 1 has to be positive because, again, the argument of a logarithm must be positive. Or in other words, x has to be greater than a negative 1. However, that is only part of the picture. If you go back to the original problem, the two component pieces here, this guy and this guy, are the ones to look at. So the second one's easier to talk about. The second one tells us that x minus 1 must be greater than 0 because, again, it's the argument of a logarithm. Therefore, x must be greater than 1. That is a cemented, fact right now. From before we even start the problem, I know x has to be greater than 1. It's just a requirement. If you look at this guy right here, you'll say, okay, well then x squared minus 1 also has to be greater than 0. And you should know, because this is how I've done it for quite some time in my videos. If you don't watch all my videos, that's fine. But the way that I solve quadratic inequalities is I just quickly graph that parabola that's been shifted down 1 unit. And I know that its zeros are at 1 and negative 1. Whoops. There we go. And I want this to be greater than 0. So I just want to find out, where is that parabola above the x-axis? Well, you can see it's above the x-axis where I've highlighted, right? For x greater than 1 and for x less than negative 1. So if I only started with this, I'm actually covering the screen with my hand, which was very stupid. But if I only started with this logarithm right here, and I said, okay, well, what are the restrictions on x? You would say x has to be greater than 1, or, let me fix that, or x could be less than negative 1. Because again, of that highlighted region, that's where our parabola, x squared minus 1, is above the x-axis or greater than 0. However, then I zoom out and I see, oh, wait, there's another restriction. X can only be greater than 1. So I will go ahead and throw this out, and I see that my final domain of this initial problem is that all x values must be greater than 1. So the domain is 1 to infinity, not including 1. But if you look at our final problem, we're saying x has to be greater than negative 1. Nope. I can't plug in, for example, x equals 0. If I try to plug in x equals 0 into the original problem, I will get the log of negative 1, and that's a no-no. So it wasn't asked in this problem for you to do this type of analysis, but you do need to be at this level by now. You're in pre-cal, You need to be at this level. You need to be thinking constantly about, what did I break when I manipulated this logarithm? Logarithms are notorious for this. That you start, when you manipulate things, you start losing domain, you start making weird assumptions. So just be very careful. In the very end, I would point at that and I would just say the domain of that, whether you want it to be or not, is 1 to infinity. And somebody would argue with you. They would say, no. I'm looking at your answer. I could see that you could plug in anything greater than -1. You could say, yeah, but that's not actually where this expression was born from. This expression was born from something else that you couldn't plug in things between -1 and 1 into. So, and you can't plug 1 into it, in fact. So just to let you know, pay attention to your initial functions, then use the domains of those initial functions to state the domain at the end. A very, very critical conversation. And that's all I really have for expanding or combining logarithms. A very critical and very important skill for calculus.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.